Chips. Every machinist makes them, but how do you manage them? This right here, this can cause you some problems. What are those problems? Well, it can damage a tool, break a tool, it can ruin finishes on your part, and it can seriously harm you or your workers if this isn't taken care of. So what can you do? Well, that's why I'm here. And if this looks familiar, it's because I'm here at MTEC. This is Mitsubishi Materials USA's Machining, Technology, and Education Center in Mooresville, North Carolina, where we're gonna be going over critical components that are gonna help us figure out how to safely manage your chips. Brian, how's it going, brother?
Good, man. How are you?
Good. You brought out the textbook for me today. What are we going over?
Yeah, we're going over chip breakers. How do they work? What's the purpose behind them? You know, there's a lot of research and development that goes into every one of these.
Yeah.
They're all made for a certain reason. And so how do we apply them? So today we're going to be doing a demo in 4140.
Okay.
So we're going to look at our light breaker for steel, LP, our medium breaker for steel, and our roughing breaker for steel. And we're going to show them where we can apply them, how depth of cut affects those breakers. Looking at these chips, they tell the story, right? The light breaker is closer to the corner of the insert, so that chip is curled quite a bit tighter. And you can see it starts to open up with a medium, and then as we move into that roughing breaker, that's your most open chip. So those are all being applied at the same depth of cut, at 70 thou depth of cut. You can use those inserts and have success breaking a chip in the same depth of cut. So, you know, when do I pick them? Where is the advantage to having a light breaker versus a roughing breaker? The disadvantage to using a light breaker, like you would a roughing breaker, is that chip is going to wear that breaker out and basically create a small crater behind the cutting edge. Well, now if I reduce my depth of cut to 20 thou,
This looks familiar.
which would be appropriate for a light breaker, I don't get a chip, I get a nest. And that's because I'm not engaging that cutting edge enough and making a thick enough chip to use that breaker to actually break the chip.
Do you got anything to show me? Can we see some cutting? What do we have on that end?
We do. We got some 4140 in here that we're going to run multiple passes on. We'll show you what those chips are going to look like with each one of those breakers.
I'm always talking about it. We're about to see it. You're gonna see some chips cut. What are you throwing at me?
First pass, we're going to look at 70 thou depth of cut with a light breaker. This should be something that we're using as we get closer to finishing.
Okay.
We're going to see that it's able to make a chip. There's going to be a lot of heat in those chips, and heat's what kills our inserts, right? So if you continue to run a light breaker all the time, you're probably not going to get the tool life that you'd like.
And we're doing this dry just for the purpose of the video, so we can see the chips, we can see the heat getting transferred to the chips, see what's happening. At the end of the day, you could throw coolant on at any time. It would change the color, it would change the temperature, correct?
Absolutely.
Let's do it. So already we're seeing some sparks there, which I've only ever seen type of melted with ceramic end mills, which are pretty trippy. They make ceramic inserts for face mills too. I can see those, they're really small. They look like there's little grains of sand getting thrown at the back.
Yep, they're being broken very short because that breaker is close to the corner of that cutting edge. All right, next one's going to be the RP at 70 thou depth of cut. So this is something where we would use for roughing.
Yeah, okay.
Yep. Ooh.
You can hear it a little more too. You can hear they have some weight to them hitting the back of the
You can hear them hitting inside the machine. It's a little bit larger chip. The curl of that chip is going to be a lot more open than what you had with the LP breaker.
Yep.
Now next one will be our RP breaker. We're going to be running at 20 thou depth of cut.
Cool.
So usually we wouldn't use a roughing breaker to try to finish with. We just want to show how that depth of cut affects generally on the minus side of things. As you get into lighter cuts, your breaker needs to be closer to the corner.
Okay.
And so these are going to be real fine. They should be pretty stringy, and you'll notice that that's the kind of chip that we get.
Almost instantly. You can tell even it's interesting seeing the sparks have like there's different sound to it. There's different shape, like to just those sparks coming off in general. And then yeah, you can see them.
So next one will be the LP breaker. This is our light one.
Again.
And we're gonna run it at the same depth of cut that we just ran the RP at.
Okay.
And you'll see that because that breaker is closer to the cutting edge, it's gonna make a manageable chip again.
Excellent. Yeah, again, you see little wider sparks. There's a softer sound. You can hear them quietly kind of hitting. You can tell these ones aren't the same shape either. Even if I wasn't looking right now, just hearing these different sounds, you can tell this one's going to be a different shape.
So now the last pass will be just showing you that LP breaker, where we should be using a finished breaker. So we're gonna reduce that depth of cut again to about 8 thou. And so now we're not gonna, we're gonna engage the cutting edge, but we're not making a thick enough chip to have the breaker actually break it. You see how slow it is too.
Super quiet, not even a sound, no sparks at all. And it's just, it's still, I think, still one strand. That's actually crazy.
Running it like you would a finish pass, right?
Yeah.
Now I got this stringy chip I can't get rid of, or it wraps around and ruins that finish.
I love that, man. I think I have a few other things to check out on another machine in your guys' facility, but I'll say something. Never did I think mill and lathe machinists would agree on something. We all love to examine our chips. David.
Jacob, good to see you again.
I'm back in mill land, baby. I was just over with some lathes.
So here we have a slotting demo that we use for one of our training classes. So we're looking at a 3-flute end mill that's designed for slotting at up to 2 times D. And then we're looking at a 4-flute end mill where we're also slotting, but we have to kind of cut back on your axial depth of cut. And then also the third approach we look at is like a high feed style end mill that's got a nice flat gash on the face of the tool. So now that we've got Z0, we can come in, we know where everything is, and this is our 3-flute end mill.
All right.
And again, it's only a 3-flute end mill, so it's giving you enough space to get the chips out at that higher depth of cut.
Barely even squeaked on that turn. That usually means that those chips are evacuating pretty well out of there, yeah?
Yep.
All right, so this next one?
Yep. So same tool, but we're at 2 times D depth of cut instead of 1 times D.
2 times D does a cut, all right. Oh,
we're a little slower here. We're at 16 inches a minute instead of a 55 or
Drop
whatever.
the spindle a little bit from 8K to 53.
Yep.
All right, so now we're dropping to a 4-flute.
Yeah, so this will be a DQ MH VRB. So a 4-flute corner radius end mill, and we're running it.
Even quieter.
8,000 RPM, 32 inches a minute, but we're only at 1 times D.
Yep. Nice. And then after this final pass, what do we have going on? We're gonna flip it over?
Yeah, so after this one, we'll look at a high feed style with a VF HVRB end mill. So it's a corner radius end mill that's got a reduced neck, so you can reach a little bit further, but on the face of the tool, you've got a flat plane gash. So that strengthens up that corner so we can run lower depth of cut, but much higher feed rate.
Nice.
So our first tool is gonna be a 6mm DQ MHDV, and we're doing a 10mm wide slot. So we've got some extra room in there where we can get a dynamic tool path in there, open that slot up relative to your tool diameter, and then you've got somewhere for your chips to go.
So now we're doing that closed pocket.
Yep. So we're ramping into depth, helical ramp into depth, and then it'll start working out.
And this is usually the biggest issue you'll have is on this first entry, correct? When it comes to your chips, if they're not exiting that spiral, once you hit the floor and you start tricodialing, that's where you'll get your breakage most likely.
Yeah, your first couple passes are where you have the least amount of room for the chip.
Yeah. I hear spindles turning, I smell some coolant. How's it going, brother?
Good, how are you?
Good, you're the final demo of the day. What are you showing us right now? What are we gonna be going over here at the DMU?
Right now we're showing some 2mm drilling. We've got a short little pilot drill just finishing up.
Nice.
But next we're gonna come in with a 25 times D.
Oh yeah.
2mm drill. Drilling is more of a continuous operation, so you have the chance to create like one long chip or many long chips that could wrap around your tool and just destroy your operation, you know?
I think something that we haven't seen on any of the other machines, we haven't even talked about today when it comes to managing your chips, is that through-spindle coolant right there.
Yeah.
That through-spindle coolant can be a lifesaver.
Absolutely.
On your machine with your features, with whatever you're attacking on your part. It can really change the game. What are your thoughts on that?
It's essential. I'd say you can't drill without it.
Interesting.
Especially if we're talking 25 times D.
So if you had to give one final piece of advice, one final thought on what you can do better to manage chips when it comes to drilling, what can you do?
Drills need to be pushed harder than you think.
Interesting.
Like when we're making a bird's nest like that and we have long chips wrapping around our tool, we're not pushing it hard enough to let that the drill geometry create the short chip.
Yeah.
So we need to push it harder and let that drill snap those chips off, break them into smaller pieces.
I think that's gonna be something I'm about to go do. My outro, summarize the day. That seems to be the theme that I'm hearing between machines. We were talking about it over at the lathe too.
Yeah.
That if you're not engaging past that landing enough, you're not even getting a chance to form the chip, you're almost just chattering, just vibrating, rubbing up against your part if you're not even taking a deep enough cut.
Correct.
So it's very interesting you mentioned that, brother.
Yeah.
Lucas, I appreciate your time on this demo. It's a beautiful part. It looks like it's going to keep getting even better.
Yep.
And I appreciate your time. I'm gonna go sum this day up.
Okay, thanks man. Take care.
All right, see you guys, thank you. Whew, that was a day. We really added some chapters to my machinist story, and I hope yours as well. Well, what did we really get into? Well, we started over in lathe land. We had the LP, the MP, and the RP, all running the same depth of cut, but different geometries, different shapes. It was the way that the chips were breaking off, coming off. And then from there, we made these little adjustments, some for the worst and some for the best. And then we moved over into my home, into mill land. We finally got over to cement mills. And there, it's really not so much talking about how we're going to manage our chips. I know this episode, we wanted to talk about the safety, the management, and we did that all day long. But the further we got along, it was more about the efficiency. And I think that's what we saw with the end mills. We started to understand different slotting techniques when you're making turns, where your chips can go and where they can't go. And then we ended on a beautiful machine, the DMU 65. 5-axis machine, we were doing drilling, flat bottom drilling. We were throwing in some end mills in there for some finishing. There was some facing, everything under the sun, wrapped up in one. And finally there is where we got to the root of the episode. Across all these machines, across all these critical components of figuring out how we can manage our chips, I think we realized something. At the end of the day, you need to push your tools for what they were meant to do. You need to push your tools and run them how they were made to be ran. I think that's what we did here today, and we did it well with the Mitsubishi team. So, you and I, now, we both know how to safely manage our chips.
For more metalworking tips and industry best practices, stay tuned for the next how-to episode and subscribe to the MSC Industrial Supply YouTube channel, a source of original manufacturing content built to make you better.